Okay, so here we go, 7.3. We are off and running, so let's see. Now, this is 7.3. We're going to finish 7.3 today is the plan, and maybe start the next section, but definitely finish 7.3. Okay, deluxe, this is word problems that are going to end up, do you know the format, right? It's going to end up having something to maximize or minimize, and then you're going to have like something, something less than or greater than, something, something less than or greater than. Makes sense. That's the setup of what we call an LP, a linear programming problem. Everybody with the game plan in general. So there's always the linear programming. What linear programming means is you have something you're trying to maximize or minimize, you know, like 3x plus 2y or whatever. You know, and then you're going to have, something blah 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 greater than or less than. Well, actually, there's two ways. Yeah, in fact, let me give you the two ways it can be. It's either going to be maximized, and these are both less than blah 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 less than, or it's going to be minimized, something like 3x plus 2y, and these are going to be blah 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 greater than blah 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 greater than a number. See if that works for us. So let me give you that exact game plan. So it's either going to be a linear program problem is going to say maximize, 3x plus 2y or whatever. And if it says max, here's what I want you to know. This will help you put this on your 3 card. If it says max, these are always less than. Well, 99% of the time, almost always. If it says minimize, something like 3x plus 2y, then blah, 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 greater than or equal to number. Blah, 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 greater than or equal to number. Does that make sense? It's always opposite. Minimum we think of as small, right? Greater. So that's what I mean by opposite. If it says minimum, you'll be thinking greater. If it says maximum, it'll be less. Why? Because you're trying to maximize things that are less than a certain, once we see a real life one, it'll make more sense. But for now, just put in your mind that there's always this opposite idea. You tracking with me? If I say max, you think big, right? But it says max goes with less. And if I say minimum, you think small, minimize it, but it goes with greater. Almost always. 99% of the time it'll go that way. So you just know that right away. That's what linear programming means. Because these will be linear equations, meaning there'll be x and y to the first power. That's what linear means. Not x squared, not y squared. That's curved, right? That's not linear lines anymore. This is called linear programming because x and y will be first power, and then we have this thing where either maximize or minimize, and that's the programming, linear programming. Okay, that's the game plan. So just know that as you do the problems in this section. Linear program. Here we go. So first off, find what you're trying to maximize or minimize. Here we go. How many pounds do I have? Minimize cost. There we go. So just grab that for. Let me just go right to that. Just hone right in on that like my target. Minimize cost. So I'm going to minimize cost. Now, where's cost? Where does it say cost? Cost $6 per pound, and regular. Deluxe is $6 per pound, so that's going to be 6D for deluxe, 3R for regular. You can use X and Y, but I think it's easier to use meaningful letters. D for deluxe, R for regular. See how I came up with that? That's what we're trying to minimize. All right, so that's what we're going to minimize. So now with that in mind, guess what I'm expecting for my equations? Greater than or less than? Remember, it's opposite. So minimum, I'm expecting these to be greater. It's almost always that way. Here we go. What's it say? Deluxe coffee mix to make 41 pounds of a blended coffee. 41 pounds. Doesn't that mean however many pounds of deluxe plus how many pounds of regular? At least. What does at least mean? Greater than or equal. See, it is. You don't even have to pay attention. It's just 41. And then the mixture contains at least 11 pounds of deluxe. Oh, that's just the D, isn't it? And that's it. That's all. I've used all the numbers. Are we good there? Now we're going to solve it. I mean, that's just the setup. And then we'll go through to solve it. So everybody good so far? See how I got those equations out of those words? So again, first step is to identify if it's a minimum or maximum. Write down what they're saying. Cost 63R. And then minimum, these are greater because it's always opposite. Maximum less, minimum greater, it's opposite. And then it just said 11 pounds of deluxe. 41 pounds of the two together. There's my equations. Now, what do I have to do from here? I have to graph them, find the shaded, what's called feasible set, take the corners, plug them into this minimize thing. Take the lowest, minimum lowest, right? That's the game plan. So I'm going to go to a fresh screen. So what was it? So it's minimize 6D plus 3R. 6D plus 3, I'm going to squeeze it in here. D plus R greater than or equal to 41. And D greater than or equal to 11. Okay, so those are going to play the role of X and Y. So to graph now, I would use my calculator. How do we graph? What do we always do to graph now? What's the first thing we get alone to graph? We always get Y alone. Who's Y? Well, I'm just going to let D be X and Y be R. You could switch it up. It doesn't really matter, but I'll just do it that way. So I'm going to get, so this is X, this is Y. So I'm going to get R alone. So R negative D plus 41. Greater than or equal to negative D plus 41. Everybody see what I did there? I just took that D and jumped it to the other side. Is that good? And the other one, whoops. The other one already is alone. So those are the two. So type that into your calculator. That means put in Y1 is negative X plus 41 on your calculator. So type that in for Y1 on your graphing calculator. And you'll get a graph. Set your window. What should we set our window here? Oh, wow, the window. Normally what I do for the window... I set, X min 0, X max 10, Y min 0, Y max 10. That's normal. But on this case, you're going to have to make your X bigger. You're going to have to make your X go all the way to like 50. Yeah, good idea. 50. Let's do that. So make your X go all the way to 50. And then for the Y, negative X plus 41, graph it. Yeah, 50 is a good way to go. So when I graphed it, I got something like this. This is 0 to 50, 0 to 10. There's what I got. Did y'all get that? Something that looks like that? Now, what about the other equation? Am I going too quick? Let me slow down for a minute. Questions I can answer so far. Yeah. Questions?
How would you know to change the X min and Y max? Or X max and Y max?
Gotcha. Yeah. So at first I would have made it 10. I just always start 0, 10, 0, 10. When you'd hit it, I think you'd get nothing, wouldn't you, at first, if you just did 0, 10, 0, 10?
Yeah.
Or almost nothing? So then if you're not seeing anything, make X bigger. Yeah, I don't have any more fancy rule than that. Yeah, if you try 0, 10, 0, 10 at first on any of these linear programming problems, hit graph. If you're not seeing anything, make X max bigger. Make X max bigger. Go to 20, go to 30, go to 40, go to 50, go to 100, whatever it takes. Yeah, there's no magic. It doesn't have to be 0 to 50. You could have made it 0 to 30. Whatever. There's no magic. You just got to see something. You just go till you have a nice looking picture. Something you can work with.
D here is equal to X, right?
What's that?
D is equal to X?
Yeah, I call dx. So the D is X and R is Y. You could have reversed them. I just happen to do it that way. Yes. So that means this is the D axis and this is the R axis, right? Because D is playing the role of X and R is playing the role of Y. Huh? We good so far?
Minus the D over on that second one?
Well, I'll explain in a second. So we all caught up to there. Now, what are we going to do with this second equation? Can we type that into our calculator? Can we go in and go y2 is 11? No. Don't do that. That'd be totally wrong. Why? Why is that wrong? y2 is 11. y2 is 11. What's wrong with that? What is d again? What is d? X, not y. Right? So we can't let that d become y1 or y2. It's not y. So we can't do that. Well, then what do we do? Yeah, we have no way of putting it on our calculator. Because the calculator, all you can graph is y1 equal, y2 equal, y3 equal. You can only graph when they have a y in them. So if an equation like this second one, d greater than or equal to 11, has only an x, right? That's x. Really, that's x greater than or equal to 11, huh? Then you're going to have to do it by hand. You can't do it on your calculator. Your calculator has to have a y to do it. Well, how do I do that then? How do I do greater than or equal to 11? You know that. You just hit the x-axis at 11, huh? Where's the x-axis? Well, that's this one. Hit it at 11. Where's 11? I don't know. Just eyeball it about here or so. I'm just kind of guessing. Something like about right there. It's a line that hits the x. See how it hit the x-axis at 11? And remember, when you only have one letter, it's just a perfectly straight line, isn't it? Perfectly straight line that hits the x-axis at 11. Calculator can't do that for you. You just have to know that by hand. Yeah?
Oh, I figured out if you go to second and then calculator, then you go to value and you put in 11, it'll give you the y.
Yes, that's how we'll find the intersection point.
Oh.
Yeah, but that isn't the graph. I'm just saying like the graph. Yeah, I'm just saying it won't graph that line for you. Yeah, we'll find some values. That's a good idea. So is everybody good to there, though? I want to make sure, because the picture is what's super important for us. So we want to get that picture on that. And so we've got a picture like that. Now, what is the shaded region? Where's the shading? Well, I don't know. This is kind of a weird one. It's supposed to be to the right, isn't it? Of both of them? Okay. Yeah. So you want the region, because it says greater, right? Both of them are greater. Greater, greater. So greater is right and up, isn't it? So where's that? Well, I would just continue these guys. I would just say, well, let him keep going. Even if it doesn't show it on the screen, let him keep going. And the shaded region is all of this. That's to the right and above. Right? Notice it goes right here on this line, and then down on the black line. Why can't the shading go up here in this middle section, right? Up here? Why can't the shading go into this zone? Because that's not to the right of the red line. It's got to be greater than 11, to the right of the 11. And it has to be above the black line, doesn't it? Right and above both lines. So it's not there. So, okay, so that's the shaded region. And now what are we supposed to do? Find the corners of the shaded region. What are the corners? This is a corner, and this is a corner. Those are the only two corners of what's called the feasible set. The shaded region is called the feasible set. Meaning this is the feasible region. Meaning this is the region that's feasible, that's allowable, that's possible. This is the region where they could do the coffee. In that, everything shaded is a possibility for their coffee mixing problem that will make, R, D plus R greater than or equal to 41 and D greater than or equal to 11. It'll satisfy both those conditions. The shaded region makes both inequalities true. That's the overlap of both inequalities. It makes both inequalities true. It's feasible. It's possible. It's allowable. You do anything in the shaded region, you're satisfying what they told you to do with the coffee setup. Right? They want D plus R at least 41. They want D at least 11. Well, anything in the shaded region makes both those A-OK. It's all feasible. But our best answer, we don't just want anything that's okay. What do we want? We want minimum cost. Well, that's going to occur at one of the corners. That's the great result of linear programming. Mathematically, I didn't prove it to you. I don't even know how to prove it. But they discovered that the best answer will always happen at one of the corners of the shaded region. So all we have to do is find the coordinates of that one, find the coordinates of that one, plug them into our calculator. Whoever's lower, minimum, lower, wins, is the best way to make the coffee plan. at the cheapest cost. Does that make sense? So let's find those coordinates. What's the coordinates of this point? I mean over and up, right? When I say coordinates, I mean two things. I mean over and up and down, right? It's always x first, then y. Or in our case, d first, then r. Huh? Over and then up and down. That's how coordinates work. Two numbers, right? Like playing Battleship or something. A5, right? So we're finding that every single dot has two numbers that go with it. So, okay, what's the coordinates of that dot? How do we find the coordinates of this dot right here? Anybody know one of the coordinates already?
0.
Which one? The second coordinate, right? It's got to be 0, because up 0. So it's over, I don't know, up 0, isn't it? It's got to be up 0, right? So here, I'm running out of room here. Let me move it up here. So yeah, so this point is over, I don't know, up 0. That's x, y, or in our case, d, r. So r is 0. R's got to be 0. So if you take that equation and you put in r0, what is that equation? It's this one. And you can just make it equal. By the way, we don't need the greater than less than anymore. Am I confusing you? You don't need the greater than less. That was just for the shading, to decide which side the shading goes on. You don't need it anymore. We can just make it equal. Because I'm just finding the thin line now, right? The thin line is the equal part. The greater is the shading, isn't it? So I'm just dealing with the line. I want to find that coordinates. Make r 0. R is 0. So D is 41. That's 41, 0, isn't it? We good there? All right. How do we find the coordinates of this other dot here? This dot right here. Over and up. How far over is it? It's got to be 11. See how it's over 11? See this? Over 11. Up, I don't know. It's got to be over 11. And then I got to find out how far up. I don't know. How am I going to find it? Well, it's over D, up R. So D is 11. So take the same equation. D plus R is 41. Same one, because it hits the black line, doesn't it? This one also, it's on both lines. It's on the red and the black. But it also hits the black, so I can use the black line equation. The D plus R is 41. And put in D as 11. D as 11. Put in D as 11. 11 plus R is 41. Subtract 11 from both sides. R is 30. Over 11 up 30. That's the coordinates at that point. Everybody see what I'm doing there? You find the corners by plugging into an equation, either the first coordinate or the second. Or you can use, well, normally we like to use our calculator, and do the intersect button, but in this case, the graph's not, we can't put that straight line on our calculator. So we just have to do it by hand. Everybody see how I found those? Right, in both cases, I used the D plus R equals 41 equation. I plugged in R is 0, because I knew R was 0. I already knew one of the coordinates. R was 0. This one I plugged in D was 11, because it was over 11. Found the other one now. We just need to check which one's better. So I'm going to just plug into the minimum function. What are we trying to minimize here? We're trying to minimize 6D. Minimize 6D plus 3R. So plug in 1130, and then plug in the second one. So let's do the first one. So 6 times 11 plus 3 times 30. And what does that equal? Equal 66 plus 90. 156. And then the second one is what? 41, 0. You guys with me? And then plug in 6 times 41. I'm getting kind of scribbly here. Plug in 6 times 41 plus 3 times 0. See how I keep plugging into 6D plus 3R? 246. So which one's lower? 246 or 156? Remember, I want minimum. So clearly the winner is 156, 1130. We should make D and R. D and R. We should make 11 pounds of deluxe coffee, 30 pounds of regular coffee, and the cost will be $156. That's the lowest price to make that mix that fits everything they want. That's the best way to do it. See how practical this is? Very, very practical. Answers business questions, very practical. So, is everybody getting the game plan? You read the words, you're going to minimize or maximize something with a couple of inequalities. Then you graph the lines. The shading, by the way, the shading is going to be simple. You don't even have to think about it. For minimum, it's always going to be shaded out. Remember, it's opposite? For minimum, the shading will always go out. For maximum, the shading will always be down here, going down to 0, 0 usually. Down. The shading will be down. It's always opposite. So as soon as you say minimum, you know the shading's out this way. You find the corners, plug them into the minimum function, take the minimum. We better try another one. Questions on that one? So these will take practice. These take a long time, don't they? We've done one problem. All right, let's try this one. All right, let me let you work on it, rather than me just diving in. Start with what you're trying to minimize or maximize. Look for that word. So I would just grab that first up. Look all over the thing. Find where it says minimum or maximum. Write that first. Give you a second. Okay, what are we trying to minimize or maximize? Well, here it is, right? Minimum premium. So start there. Minimum. And what are we trying to minimize? Minimum premium. Premium. Where does it talk about premium? I don't know. Oh, premium. Yeah, thanks. I couldn't find it. 50, 40. So A is 50, B is 40. So 50A plus 40B. Everybody see that? The minimum is not a greater than less than, is it? Right? Notice the setup. It's just 50A plus 40B. No equals, no greater, no less. That's for the other parts. Everybody see how I did that first off? Right? I just looked for the word minimum or maximum. It said minimum premium. Then I went up to premium. 50A, 40B. There we go. That means however many units of policy A, they're $50 a unit. However many units, so this is an insurance policy. Policy A, you can buy several units of it. Every unit of policy A covers you for fire and theft at $10,000, liability for $180, and cost $50. See what that's saying? Every unit of policy B, there's a whole bunch of policy B units you can buy. You can buy it in increments, units, right? Every unit of policy B covers you for $15,000 fire and theft, $120,000 liability, and is $40 per unit. So, minimize the premium. There we go. Now, write your inequality statements. Now, this says minimum, so what are my inequality statements going to be? It's opposite, right? It's always opposite. So they're going to be greater than, aren't they? And when we go to the shading, where's the shading going to be? Out or in? Out. It's going to be, some kind of lines or whatever, blah, blah. And it's going to be out because it's minimum. It's opposite. Minimum, you shade out. Max, you shade in. So it's opposite. You're trying to find the most inward, the lowest among shading that goes forever out. That's the idea. You're trying to find the lowest among shading that goes up, up, and away. So, all right. So give it a try. See if you can write those. Give you a second on that. Feel free to check with those around you. talk it out, work it out. I'm gonna wander around. Let me help you. This is the part that's tricky. I know this gives people trouble. Well, try something. Glad to help. Feel free to compare to those nearby you.
Oh, no,
Right there. Doing okay? So see the first statement, everybody? It needs at least 450,000 fire. So 450,000 fire. 400. So just hone in on that. $450,000 fire. See how I'm finding that in the word? I'm just going up to the words here. $450,000 fire. So I'm gonna write 450,000 fire. This is gonna be a fire statement. Right? Oh, fire and theft, I guess. I didn't read the rest of the word. Fire and theft. Okay, so fire and theft, A and B. 10,000 A plus 15,000 B. Good so far? So that's pretty straight ahead. Try that. Now get the other one. Make that a little nicer. Good. And then the second one, 5,400,000, and that's liability. And then you grab the liability numbers, huh? 180,000 A and 120,000 B. Good? There's our setup. We're ready to put them in the calculator. Now this is nice. This time we have Y in both cases. Well, Y is B, right? So we can just put them, get B alone in both those, and just type them both into your calculator. We'll let the calculator do the work this time. Now last one was hard because one of the equations didn't have a Y, so we had to do everything by hand. Most of them will be like this. They'll have a Y. So get B, Y, B alone in both equations now. Use your calculator. Those are big, ugly numbers, huh? So get B alone in both of these. So I'll grab. So how do you get B alone? Just grab the whole A thing and jump it over. So this will become 15,000 B greater than or equal to negative 10,000 A plus 450,000, and then just divide through by 15,000. Because you got to get B alone, right? And you know what, guys? If you want to, you can just type it into your calculator just like that. Doesn't matter. You don't have to do a bunch of fancy math. Just type it in. Now it's probably easier. Just type it in. Boom. Right? This is y2. This right here, or y1 I mean. That'll be y1. Just type it in just like that. Except make your a x. Right? You with me? You don't need to reduce it and do fancy stuff. I don't know. It might be easier. Whatever. Whatever you want to do. Yeah, it might. Yeah, maybe I will. It'll probably be easier. So this is maybe I will. So B. Okay, now how do you reduce a 10,000 over 15,000? That's 10 over 15. The thousands just cut out, don't they? And it's negative. And how do you reduce 10 over 15? 10 over 15 divided by 5. Top and bottom 2/3. And then this other one is, I don't know. What is it?
Well, you get divided by 15,000.
Yeah, 2 would be 30. What is it?
3.
What is it?
3 and 2.
Oh, it's 3 halves?
Yeah.
Oh. Yeah, so just divide by 15,000. Top and bottom. Oh, I guess that doesn't work. Here, I'm confused. So cut out the zeros. It's going to be 450 over 15. Is it just 30?
Yeah.
Okay. Yeah, it's just divide. It's just 30. Good there? Yeah, just divide it. Yeah, don't do anything fancy. Just divide it. It's 30. So everybody see what I did there? Got B alone. Take the second equation now and get B alone. So grab this A and jump it over. What will it become? It'll become 120,000 B greater than or equal to negative 180,000 A plus 5,400,000. Divide through by 120,000. Again, reduce that. How do you reduce 180 over 120? You could just leave it like that. Who cares? You know, if it bugs you, just leave it like that. The other one, though, divide the other one. What is the other? What's 5,400,000 divided by 120? 44? 45? 45. You all see what I'm doing there? You don't have to redo. Oh, can you read that? It's in the little marker area. You don't have to reduce the slope there. Who cares? Your calculator can handle it. I would just make it minus 180 over 120. Just get rid of the thousands. But the number on the right, I would divide. That'll be easier for you. Everybody good? So I got Y alone, B alone in both of those. So now type them into your calculator. Y1, Y2, hit the graph button. See what you get. Give you a second. How we doing? Let me jump in. I better get this moving. These take a long time. So, okay, so the two equations now. We're minimizing. B is 50A plus 40B. I was minimizing 50A plus 40B. And we've got b greater than or equal to negative 2/3 a plus 30. Second one is b greater than or equal to negative. Okay, and so when you go, so type them into your calculator, y1, y2. So this will be y1, this will be y2. You with me? Type those into your calculator. How we doing? Type those in, minus 2/3. Make that x, right? You make that ax. You know, just make x, right? And the second one. Now, do y'all see the y values go up to 30 and 45? So you're going to have to make your graph go up to like 50 on the y. You're going to have to make the y max 50 on your window. Y max is 50 because they're going way up. And I make my x is still going 0 to 50 as well. There's my x max. So my x max and y max are both 50. I've got a nice little graph. I'm getting something that looks sort of like that and sort of like that. Y'all getting that? So I made x and y max both 50. I typed in those two equations. Actually, mine's a little bit more like this. How we doing? Y'all able to get that? Let me know if you're having trouble getting that. Oh, good. Yeah. Is able to get that graph on your screen? Now, where's the shading? I don't even need to look at it. Well, they both say greater, but so the shading's out here, huh? And plus, minimum always means opposite. Shading's out. So where's my corners? Here, here, and here. Everybody see how I'm finding the corners of the shaded region? Everybody see how I could do my shading a little nicer to see. Right? The shading is all that. So see those three purple corners? Those are the three corners of the feasible region, of the shaded region. Aren't they? So now I've got to find the coordinates of those three dots, plug them into the minimum thing, and take the lowest, minimum. We're almost done with this problem. All right, what are the coordinates of this thing? How are we going to find the coordinates? Well, can you guys tell me what this one is just by looking at the equations? It's going to be over 0, up what? Look at these numbers. Remember, those are the numbers where it hits the y-axis? One of them's at 30. That's got to be this one lower. This one's at 45. That's got to be 0, 45, doesn't it? Right? The two places it hits are 30 and 45. The lower one's 30. The higher one's 45. Good there. Okay. How do we find this one in the middle? Second calc intersect. Yeah. Because this time they're both on the screen. So we go second calc intersect. Let's hit enter, enter, enter. I'm getting what? 18, 18? 18, 18. Whoops, I bumped the screen. 18, 18. Now, how do we find that third corner of the feasible set? Yeah, that one is over something up 0, isn't it? That one's over something up 0. Well, what? Over what up 0? How can we find it? Yeah, letting y equal 0, huh? Which equation? There's two equations, so I'm going to let y, it's a, b. This is b and a. I'm going to let b, I'm going to plug in b for 0, but to which equation? The line, this line that hits here is the line that's up 30. It's this one, isn't it? So I'm going to plug it. So take that one, take b, and just make it equals. Equals minus 2/3 a plus, or probably you can just look in your table. Yeah, look at your table. Hit second table. Yeah, is that working for y'all?
Yeah, I got 45.
Yeah, hit second table, and go over until you find y0. Or just move till you find y0. Is that where it's at? It's the first equation. Now you got to find y10. Yeah, just go down until you find it on your table. 45. Yeah, beautiful. That's easier. So do second table y1 is 0, because this is the y1 equation. Find out where y1 is 0, you'll see the x value 45. That's a good idea. Just do the table. Don't need to do any. So it's nice when they're both on our calculator, when they both have a y value, we can do everything on the calculator. How are we doing? Is this making sense? I'm deathly afraid I'm doing the Charlie Brown teacher thing and it's not coming through. If this doesn't come through, you're in big trouble. They're all like this. You need to get this down. Because we're going to do this again and again in the next two sections. Like math, math builds. You can't not get something. Well, you can, but you failed class. Because it builds. It doesn't go away. You can't check out for like part of a subject. Because it builds and builds and builds. Does it? It's like learning a language. Can't do bad in Chinese 1 and hope everything goes fine in Chinese 2. It doesn't work that way. They are related. Everything will relate to this. Is this making sense? So therefore, I'm saying this, you'll ask me, or you'll come to my office hours, you go to see the tutors, get the help you need, look over the YouTubes again and again as you solve these problems. The process is kind of the same every time. Do you see what I did, right? Once I had these equations, I put them in my calculator, found the intersect. That one's at 45 by looking at the 30 and the 45. This one I used the second table. So the x-axis one I find by the table. You probably could have found that one on the table too, huh? Probably could find both of them on the table if you want, second table. But the one in the middle is the intersection of the two lines, isn't it? So I found that was second intersect.
That's only when they both connect on lines?
That's only when they're both lines that I typed into my calculator. Like the last one, this last problem, I didn't type, right, the red line there, I didn't type in my calculator. It didn't have a Y. Yeah. So this is normal. That was weird. This is normal. Normally they're both in your calculator. You find the intersection in the middle. All right, we gotta figure out which one of these is the best answer. So we gotta type in this one, or plug in, this one, into what? Into this minimum function. And take the lowest, the minimum, right? So one more screen, and we'll finally be done. So what are we trying to minimize? We're minimizing 50a plus 40b. 50a plus 40b. And what are my options? 0, 45, 18, 18. So 0, 45, 18, 18. And what's the other one? 45, 0? Or no, is that right? Yeah, 45, 0. Okay, so plug them in. Here we go. 50 times 0 plus 40 times 45. Next one is 50 times 18 plus 40 times 18. The third one is 50 times 45 plus 40 times. Does somebody have answers for me? What's the first one? Oh, here. I'll do them. I can never tell one. So yeah, 1800, 1620, and what is it? 2250? All right, who's the minimum? This one, 1620 is the lowest number. It happens at 1818. So they should have 18 units of policy A, 18 units of policy B. That will cost them $1,620 a year to provide the insurance coverage they need. That's the cheapest way to provide their insurance coverage needs. How are we doing? That's only 2 problems. Well, 3 counting last week. All right, so I'm going to move on. I'm not going to be. So where do we start on all these linear programming problems? What do we do first? Minimum, maximum, right?
Yeah.
Where does it say minimum, maximum? Anywhere.
It says it at the end, it says,
Minimize the total cost. So start there. There's our goal. That's like an archer looking at the target first up. Minimize total cost. All right, we're minimizing. And where's total cost? Cost per load. 76.41. 76 small trucks, 41 large trucks. Is that good? There? All right, and then we need to write, so there's our minimum. Now we're going to need to write some inequalities. Now, if that says minimum, what are all of our inequalities going to be? They're going to be greater, aren't they? And the shading's going to be out again, with the same thing again, huh? All right, here we go. Tina's company, blah, 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 carrying capacity, Tina, wait, is it all, oh, did I? So let's see. Tina must deliver 180 cubic yards per day. She must deliver that many cubic yards. See what that says? Cubic yards. Where else do you know, I survived physics was the hardest thing I took at junior college when I was up in Sacramento going to junior college. Hardest thing I took was physics. It was like math with all word problems. And I survived physics by following the yellow brick road of units. Before that, I hated units. I always thought, why do they give me those yards and cubic yards and whatever? They bugged me. But then I got to physics, and I'd read crazy big word problems, and I'd go, I have no idea. I took the magnetism physics, where there were like flux fields and power things, and I just go, oh my goodness, making my head spin. But then I go, just follow the units. Follow the units. So this will say what? Cubic yards. Where else do you see cubic yards? Cubic yard, that's yards cubed, right? This and this must go with this. Yeah. You don't need to understand everything. Just follow the yellow brick road of the units. I survived physics. It was like light through a dark path for me. I would just follow the units. I mean, it didn't always work out, but often, when I had no idea what all the words were saying, I would follow the units. So, 30S plus 60L 180, right? So I'm doing that. Cubic yards for small, large, 30, 60, 180. See how that works? What comes next? Total requires total number of loads per day, 9. Loads per day. That means small trucks put large trucks, 9. Huh. That's just loads. There we go. Does that make sense? I'll just go ... from there. So it's just like the last one then. Get Y alone, type them into your calculator.
I think the hardest part is just setting it up.
Yeah, that's what I'm thinking. I'll do some setups with you.
This very confuses me, setting
The setup is the hardest. Is that good there? I'll move on if you got that one down. So, yeah, so I just grabbed the 180 and it said cubic yards, so I used the cubic yard stuff. And then the other part, the 9, I'd already used everything. To see how I knew it was just S plus L 9? Because I'd already used everything else. It wasn't cubic yards or anything. Okay, it takes 13 units of carbohydrates, 70, whatever, blah, blah, blah. Where do we start? Let me let you start. Yeah, let me let you start rather than me doing it. I think you'll get more out of it if I give you a minute. We don't have a lot of minutes. Let me give you 1 or 2 minutes. What are they asking you to maximize or minimize? What's it say? It says minimum cost. You can find it there. You can find it in some other places. Minimum cost, right? Minimum cost. Where's cost? The meat is $3.50. The cheese is $4.50. $3.50 meat, $4.50 cheese. Getting the hang of this? Seeming a little better? I just find minimum or maximum. Cost, go find cost, boom, boom. Meat and cheese, X and Y. And I knew those were my variables, because that's what they're asking me for in the end. Pounds of meat, pounds of cheese, huh? So meat and cheese is what are going to be my variables. What they're asking for is what's going to be your variables. You tracking with me? Like the last problem, they were asking us for how many small truck, right? Number of loads in the large truck, number of loads in the small truck, so large and small were going to be my two variables. This one, it's meat and cheese. Okay, can you write the other inequalities? It's going to be less than. These have all been minimum, haven't they? They're all minimum, minimum, minimum. Well, which means they're greater. It's opposite. What am I doing? Minimum means greater. Right? Did I do that wrong last time? Yeah, no, sorry. Greater. So, okay. Can you write the other equations? Another minute. You just got to put together what they're saying. They're talking about carbohydrates and they're talking about protein. So I would have a carbo and a protein line. Talking about carbohydrates and protein. They're saying
Wouldn't it be meat and cheese?
meat and cheese are our variables. Yeah, so remember like those other ones we set up. So meat and cheese are our variables. Carbo and protein is what they're speaking about. Let me let you, give you a minute. See what you can straighten out. But we've already got meat and cheese up there. So then I put carbo and protein. See what you can do there. Okay, what does it say? 13 units of carbo, 7 units of protein. Meat is 2 carbo, 2 protein. Meat is 2 carbo, 2 protein. Cheese is 3 carbo, 1 protein. There we go. Everybody good with that? So I followed that out. So what you got to do for yourself, what I had to do for myself, is so you got these on YouTube, is I had to spend time, but not just, because I'd see it in class, it always seemed so easy when the teacher did it. Like, oh, why didn't I see that? Obviously. But there's a difference between watching me lead you logically through it, because I'm prompting you with all the right thoughts and questions. You got to learn to do that for yourself. So you got to cover up my work. Like, don't, like, play, but well, you don't have to cover up. I'm doing what I had to do in my olden days when there was no YouTube. I would just take down all the notes, and then I would go back and try the problems there. I'd cover up what the teacher had done and just try reading the word problem myself and go, what would I do? And then I would look at his work or her work when I was stuck. So you have that on the YouTube. Play this back. Well, you're going to do the homework, right? As you do the homework, try it yourself first. As you get stuck, look back at the YouTube for the help. But try it yourself. The more you try it yourself, like learning to walk or learn anything else, you'll get it down. They're kind of the same every time. Yeah, let's have a maximum one. Yeah, there we go. Maximum. All right. We got a maximum one. It's really the same. It just reverses everything. So go ahead, try that. Write what you're trying to maximize first off. Here we go. You ready? What are we maximizing? We're maximizing revenue. Where does it say anything about revenue? $13, and so mailbox 13M and toy 18T for toys. Mailbox and toys, huh? Those are our clearly, look here, mailbox, toys. Those are clearly our variables, aren't they? Okay, so there's our max. Now, what else do they speak of in this problem? Looks like they're talking about Carlo and Anita. So Carlo and Anita are going to be the sideways parts. You get what I mean? See how I looked for, like last time it was carbohydrates and protein. Right? Can you write the facts for Carlo and Anita? What does it say? Each mailbox, 1 hour from Carlo. Carlo mailbox, 1. See? 1 Carlo mailbox. 2 from Anita. This is mailbox Anita. Mailbox Anita, 2. Each toy, 1 hour Carlo. Toy is 1 hour Carlo. 3 hours Anita. Bring down the M's. See how I just bring down the M's and the T's straight down? Add them up. Now is it going to tell me that the total max means big, so the opposite is less, huh? Remember, it's always less. Max is big, so then these are both less. And then what? Oh, there's Carlo is 7. Anita is 18. There we go. The rest is the same. You're going to end up graphing. This is both less, so you're going to have like one line, another line, and you're going to have the shading in here because it's less. And you're going to have these 3 corners that you find. So to see how that one's, because max, it's always opposite, right? So max is big, the shading is inside. See the difference? And you find those 3 corners. On that one, it's easy. This will take hours and hours of your life. But if you do it, you'll be able to do word problems. You'll learn how to do these. Jamal, planning to, okay, first up, max or min? Max is what Jamal earns. Okay, how do I find what Jamal earns? Where's that?
It's the percentages of the interest.
That's the percentages. Citibank 7%.
Do we write them like
Oh, and here it is, Citibank and State Bank. Those are my 2 variables. So yeah, make a decimal, 0.07 Citibank. And 11% for State Bank. There's what I'm maximizing. See how I figured that out right away? That's the interest. He's maximizing the interest he earns. Okay, what are my other things? Well, he's going to invest $16,000 in city or state, city or state. So that's city plus state. Now max means these are less than. So I came up with that one. He's going to invest $16,000 in city or state. That means those total $16,000, don't they? Or less. Next one, he wants to invest at least $1,000 in city. So city, oh, this is different. At least is great. This one's tricky. But no more than 12. Oh, okay, yeah, this is a tricky one. I'm glad I showed you this one. City is between 1,000. That's what they're saying. At least 1,000, no more than 12. So that's a wrinkle they don't usually do. City's being trapped between 2 numbers, 1,000 and 12,000. State Bank does not insure more. Sensitive redemption, he wants to invest no more than this amount. So no more than 11,000. So State Bank is at most 11,000. Yeah, that one's a little weird. So yeah, so when you go to graph that, let me show you something about graphing and we'll be done. When you go to graph that one, remember this is x, y, x, y. This is x. This is y. So this one you can put in your calculator. That'll be y2 equals 11,000, which will be a line at 11,000 on your calculator. This one you'll get y alone here. And you'll have s negative c plus 16,000. So that'll be y2. or y1, I guess it's y1. Y1. So that'll be something that comes down like that. And then this one, this is x. It has no y. No y here. So you have to just think of it by yourself, right? You can't put it into the calculator. Are you tracking with me? Do y'all see this one? There's no y there. It's only x. So what does that say? X goes from 1,000 to 12,000. That's what that's saying. It's trapped in between 1,000 and 12,000. So it's going to be this shaded region in between those. So the corners of that shaded region would be here, 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 and here. Because it's less. It's under all those lines. Does that make sense? Got to find all those corners, plug them into the thing you're maximizing. All right. That was a lot of